Hello everyone, this is Kalpana here. In this video, we are going to see how to form a partial differential equation from the given relation using by eliminating the arbitrary constants method. Okay, we'll see a small intro part and later we'll go for an example. So let's get going. So here, all we need to learn is notations. Okay. Dou z by dou x equal to p, dou z by dou y equal to q, dou square z by dou x square equal to r, dou square z by dou x dou y equal to s, dou square z by dou y square equal to t. Okay, here x and y are independent variables and z is a dependent variable. Okay, also z is a function of x and y, we can see. Well, now when a relation, say some psi of x, y, z, a and b equal to 0 is given, we need to form a partial differential equation from this relation. Okay, so here a and b are arbitrary constants. So we'll form a partial differential equation by, if you consider it as some equation 1, we'll just partially differentiate this relation, that is 1, this relation otherwise, with respect to x by partially differentiating this relation with respect to x. We'll get one equation, we'll consider that equation as equation 2, and again by partially differentiating the relation with respect to y, we'll get another equation, we'll consider it as equation 3, and from 1, 2 and 3 we'll get something like this, an equation otherwise, some f of x, y, z, p, q equal to 0, which is the required partial differential equation. Okay, so in this process the constants, arbitrary constants a and b gets eliminated, then that results to f of x, y, z, p, q equal to 0, which is the required partial differential equation. Okay, so you need to remember these 1, 2, 3, 4, 5 notations. Fine. Now coming to the problem. Form the partial differential equation by eliminating the arbitrary constants a, b from z equal to x square plus a into y square plus b. Solution. Given z equal to x square plus a into y square plus b. Okay, consider this as equation 1. Okay, now partially differentiating one with respect to x. Okay, dou by dou x of z equal to, you need to partially differentiate 1, both sides of 1 with respect to x. Okay, dou by dou x of the RHS part. From this you'll get dou z by dou x equal to, here we need to partially differentiate with respect to x, right? So y will be treated as constant, but here y square b is considered as constant, right? So how we'll write this? We can write this as y square plus b, which is a constant, into partial derivative of the term involving variable x. Right? Fine. Since we know that dou z by dou x is a notation p, just replace dou z by dou x by p, since dou z by dou x equal to p, right? equal to y square plus b into dou by dou x of the first term x square plus dou by dou x of constant, right? This gives us y square plus b into partial derivative of x square with respect to x is 2x plus partial derivative of a constant with respect to x is 0, right? So you'll get y square plus b into 2x. Right? So this gives us p equal to y square plus b into 2x. From this we'll get p equal to y square plus b into 2x, or we can write this as y square plus b into 2x equal to p. From this we'll get y square plus b equal to p by, just take this 2x to RHS, you'll get p by 2x. Therefore, y square plus b equal to p by 2x. Consider as equation 2. See, here in the question you're having y square plus b, right? If you'll replace y square plus b by p by 2x, this constant, arbitrary constants will be eliminated, right? It gets eliminated by replacing y square plus b by p by 2x. Okay, fine. So now we got equation 2 by partially differentiating 1 with respect to x. Now we'll partially differentiate 1 with respect to y. Now partially differentiating 1 with respect to y, okay, on both sides of the equation, okay. Dou by dou y of z equal to dou by dou y of the RHS part, right? So here we need to partially differentiate the terms with respect to y. So x is treated as constant. So here x square plus a is treated as constant. Now we'll write this as dou z by dou y equal to constant x square plus a into partial derivative of y square plus p with respect to y. Okay, you need to include the term involving y here because we are partially differentiating this with respect to y. Okay, fine. Now we have a notation. Since dou z by dou y equal to q, right? So we'll replace this by q equal to x square plus a into dou by dou y of the first term y square plus dou by dou y of constant b, which gives us q equal to x square plus a into partial derivative of y square with respect to y is 2y plus partial derivative of constant with respect to y is 0, which gives us q equal to x square plus a into 2y, right? Now we can write this equation as x square plus a into 2y equal to q, right? Now take this 2y to RHS, we'll get x square plus a equal to q by 2y, right? So now you can consider as equation 2. Okay, see, in the question you're having x square plus a. If this can be replaced by a by 2y, the constant a will be eliminated. Okay, fine. Now you need to consider it as equation 3. Already we have equation 2, right? Fine. We got equation 2, which is y square plus b equal to p by 2x, which is equation 2, and x square plus a equal to q by 2y, which is equation 3, right? Now, by replacing x plus a by equation 3, okay, from equation, just substitute 2 and 3 in equation 1 so that the arbitrary constants gets eliminated. Okay, let's see that. Now, substitute 2 and 3 in 1. Okay, we have 1, z equal to x square plus a, y square plus b, which is 1, right? Is equal to, just replace it by equation 3, you will get q by 2y, and replace it by p by 2x. Okay, since by 2 and 3, since from 1, fine.
Now we can write this as PQ by 2×2 4xy, right? Or PQ by 4xy equal to z. Now take this 4xy to RHS, you'll get Py equal to 4xyz.
Therefore, PQ equal to 4xyz, which is the required partial differential equation. Okay, so this is of f of x, y, z, p, q equal to 0 form. Okay, if you take this to LHS, you will get pq minus 4xy equal to 0, which is of f of x, y, z, pq equal to 0 form. See, we don't have any arbitrary constants here, right? We have y, z, x, y, z, p, q. Okay, this is the required partial differential equation. Well, we have seen how to form a partial differential equation from the given relation using elimination of arbitrary constants. So I hope you'll understand. We'll see you in the next video. Until then, bye bye.